Assalamualaikum warahmatullahi wabarakatuh. My name is Irsyad Syahmi bin Nur Susaini. My matric number is DE210109. So today our group will present about our group project for DSP. We are from group 5 section 1. Our group members is Muhammad Daniel bin Ahmad Kamal, matric number DE210072. Then Muhammad Farid bin Samsul Kaha, DE210095. Then Syahrul Adli bin Zulfikar Husni, DE210106. Irsyad Syahmi bin Nur Susaini, DE210109. And Muhammad Hazim Syahmi bin Muhammad Yusof, DE210091. Okay. For introduction, filters are used in signal processing to remove unwanted elements from a signal. They can suppress certain frequencies or frequency range. Filters can operate in the frequency domain, but they can also reduce coloration without frequency domain operations, particularly in image processing. There are two main types of digital filters: finite impulse response (FIR) and infinite impulse response (IIR). For FIR, filters can achieve performance level not possible with analog filters but require efficient digital signal processes due to the large number of computation. IIR filters use feedback and resemble conventional filters, resulting in an infinite impulse response. Unlike FIR filters, IIR filters require fewer coefficients due to feedback, but there is no computational advantage when the output is decimated.
Okay, for the problem statement, finite impulse response (FIR) and infinite impulse response (IIR) are two types of digital filter used to process signals. They are both used to remove unwanted frequency from a signal. However, FIR and IIR have different in characteristics, effectiveness, and function in digital signal processing. The both filters are also have a little bit different in pattern.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim Syahmi bin Muhammad Yusof. My matrix number is DE210091. Okay, so I will proceed the presentation with objective. Okay, for this project, there were three objectives, which is the first objective is the filter should be designed to remove as much noise as possible while preserving the original signal. The second objective for this project is to know the comparison of the performance between two filters, which is the FIR filters and the IIR filters. The third objective is the characteristic of finite impulse response (FIR) and the infinite impulse response, which is IIR filter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Syamsukaha and my number metric is DE210095. So I will continue this video presentation for the methodology question part. For the first question is digital signal processing technique. DSP application can be implemented on the Arduino microcontroller platform. Arduino can be used for tasks like analog signal processing, audio signal processing, and frequency analysis. Arduino reads analog signals through its analog input ports and process them using algorithm defined in the Arduino IDE. Arduino can sample, process, and output audio at the sampling rate close to 44.1 kHz. Arduino can analyze the frequency of an incoming signal by reading it through its analog input ports and processing it with algorithm written in the Arduino IDE. And online courses are available that utilize the Arduino platform to teach DSP. For the next question is filter system representation which use Z transform technique. The Z transform technique can be used in Arduino to represent the filter system. For FIR and IR filter, stabilize, analyze, and block diagram can be described using the Z transform technique. The Z transform technique enables the design and analysis of FIR and IR filter in Arduino. The challenge in filter design is to find the smallest filter that can be specific requirement, which can be visually represented and examined using the Z transform technique. The Z transform technique allows us for the examination of filter stability and the relationship between coefficient, poles, and zeros. Block diagrams are used with the Z transform technique to visualize filter system equations. The Z transform technique can be applied to design and analyze FIR and IR filters in Arduino.
Okay, so next I will proceed with the third question, which is explain the FIR and IIR filters theory and concept. Okay, so the answer for this question is digital signal processing with Arduino involve two types of filter, which is the first one is FIR, which is finite impulse response, and the second one is IIR, which is infinite impulse response. Okay, the FIR filters use past and present input values to generate the output and support linear phase filtering. Finite impulse response filters also offers greater flexibility and stability than the infinite impulse response filters. Okay, the IIR filters or the infinite impulse response filters combine previous output values with present and past input values to produce the current output. Okay, the IIR filters also do not support linear phase filtering and exhibit recursive behavior, relying on both input and the previous output. And next is the finite impulse response filters are more effective but require more processing power and setup effort compared to the infinite impulse response filters. Okay, the FIR filters offer linear phase filtering while the infinite impulse response filters do not. And lastly, the IIR filters are recursive while FIR filters are not. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syarul Adi bin Zulfikar Hosni. My numeric is DE20106. So today I will present the simulation of the IIR filter and the FIR filter. So first I will start with the IIR filter. So I'm using this Arduino IDE software. So first off, I will start recording with float x and 1 equal to 0, float y and 1 equal to 0, in k equal to 0. Next void setup, serial begin 11,000, 5,200. And next void loop. So to test the filter on the Arduino, we'll start by coding the test signal. So float k equal to micros over 1.0 E6, float xn equal to sin 2 times pi times 2 times t plus 0.2 times sine 2 times pi times 50 times t. So this is a raw signal. So next we'll implement the difference equation for the filter. So the new value of the filtered signal yn is equal to a weight sum of the previous value of the filter signal yn1 and the current and previous values of the raw signal xn and x1. Next is to complete all the code, store the values of the raw and filtered signal so that they can be used in the next iteration of the loop function. Though there's also one millisecond delay so that the loop function updates at a frequency of 1 kilohertz. So after put all of this coding, we can verify, and don't forget to plug in your Arduino. So after then compiling, we upload code into the Arduino. Then we go to tools and serial photo. So this is the result from the coding. So don't forget to set the bulb here 11,000, 5,200. So here's the result. The filter has largely removed the high frequency component from the test signal. However, the magnitude is slightly attenuated and there's a short delay. So that's all for IIR signal. IIR filter. Okay, for the next one is the FIR filter. So I will be using the MATLAB software. First, we start with clear all of the coding before. Next, we set the time specification. So S equal to 100, F equal to 5, T equal to 5, N equal to 0 of 1 over Fs over T. So next, we set the value of X equal to sin 2 times pi times F times N. So this equation will plot X. So next is Z equal to AWGN X1. So we need to add white Gaussian noise to the vector signal. So this syntax assumes the power of X. So this will give the plot Z noisy signal, plot ABS FFT Z spectrum signal. So next we will set the value of 0, value of O equal to 10. So this is the N order. And next WC equal to 2 times pi times F over Fs. So this is to normalize cutoff frequency. So next is butter filter. BA equal to butter O WC. Get the fracs BA FB tool BA. Next is XF equal to filter BAZ. So plot XF. So FIR filter design, set the value of O 0. We set the value of O equal to 10. B equal to FIRL OWC. XF filter B1Z. And then subplot 3 to 2, plot Z, title, noisy signal, subplot 3 to 4, get the filters in the FIR, and subplot 3 to 6 to get the fracs B8. And lastly, we end the coding with the FB tool B1. So this subplot divides the current figure into a grid and creates axes in the position specified by this number. So MATLAB numbers, subplot positions by row. The first subplot is the first column of the first row. The second subplot is the second column of the first row, and so on. Okay, next we run the simulation. So this is the result from the coding at the MATLAB. So this is the magnitude response dB. This is the phase response. And this is the magnitude response and phase response. So that's all for the simulation. Thank you.
Okay, for the conclusion, the choice between FIR and IIR filter depends on the specific requirement on the application. FIR filter are preferred when precise frequency control, linear phase response, and accurate frequency characterization are needed. IIR filter are often chosen for the effectiveness, lower memory requirement, and ability to exhibit resonant behavior. When deciding between FIR and IIR filter, consider factors such as desired performance, available processing power, memory limitation, and the trade-off between required frequency response and stability. Thank you.